Good morning, everyone. Welcome to Connect2STEM TV. We're so glad you joined us on this final Saturday of our sessions, and we are going to kick it off today with a welcome from our Be Kind crew. And so here's Sunny.
Hey everyone, I'm Sunny with the Be Kind crew, and I want to welcome you to Connect2STEM TV. Organized by the University of Arizona College of Medicine, Phoenix, in partnership with Cox Communication and the Arizona Sci-Tech Festival. Who's ready to get nerdy? Today we are going to have fun and work on a STEM project. Be sure to have your materials. Get ready, set, let's go.
Great, so let's watch our first presentation today, which is a sticky ice experiment. And here is Anika.
Hello, today we're going to be doing the sticky ice science experiment. The challenge is to lift an ice cube using only a string and salt. With a serious wow factor, this science experiment is a fun, simple way to learn about salt effects on the freezing point of water. So the materials you're going to need are 3 small bowls, one with ice, one with salt, and one with water, and a piece of string. First, we're going to place a few ice cubes in the water, just like that. And then you're going to try to use the string to try to lift the ice out of the water. So here we go. As you can see, it is not working out. So what we're going to do is we're going to take the string and we're going to lay it across the ice, just like that. And then you're going to sprinkle some salt on top of it. And then we're going to wait 60 seconds and then lift the string. So what is the science behind the sticky ice? The salt sprinkled on the ice causes it to start to melt, just as salt added to icy roads does in the winter. The water freezes at 32 degrees Fahrenheit, which is 0 degrees in Celsius. But when the salt touches the ice, it lowers the freezing point to much lower than that. In order for the ice to melt, however, it has to absorb heat. The heat that is absorbed comes from what's around it, the water near the ice cube. Some of this water becomes so cold it refreezes and the string becomes trapped. The string is now stuck and you can lift the ice cube out from the water. So here we go. And whoa, would you look at that? As you can see, the ice has trapped the string inside. And there you go. You've just created sticky ice.
Great. Well, I'm going to stop sharing my screen and I am going to let Anika take over and talk to you about the sticky rice experiment. And Anika, I'm sure there's a lot of questions. So if you have questions, don't forget, throw those in the chat and Anika will be able to answer them for you. Take it away, Anika.
Thank you. Hello, my name is Anika Islam. I am a second-year student at Arizona State University, Barrett the Honors College. And I'm studying biological sciences and business healthcare. And outside of academics, I'm also involved in the Barrett Honors College Council, She's the First, and the Swift Youth Club. So we're going to see, how did the experiment go for all of you? All right, it looks like we have a couple questions coming in. One of them is, how much salt do you use? So you can just use a pinch of salt just to cover the end of the string, however much you want to cover. It's completely up to you how much salt it works. Oh, awesome. One of the students says that it worked out. All right. Another question is there any specific amount of water? So no, there's no specific amount of water. As long as you have at least this much in the cup, the experiment should work. Another question is, how much ice do you put in the water cup? So as long as it's just as much as water as there is ice, you're all good to go. It's completely up to you how much of each material you want to use for the experiment. All right, another question is the water cold or warm? As I would recommend room temperature water. All right, awesome. A lot of people are saying the experiment worked. That's awesome. All right, so if you don't have the materials at the moment, you can take note of the materials right now, and then this session is being recorded, so you can re-watch the experiment and follow along at a later time. A question we have is Himalayan salt okay? And yes, you can use any form of salt. All right. Someone pointed out that the ice is technically not sticky. That's a great observation. So does anyone know why it's called the sticky ice experiment, or where does that come from? All right, great. So you are correct. The ice isn't necessarily sticky, but when you sprinkle the salt on the ice, it causes it to start melting. And that's because it lowers the freezing point of the ice. So then it uses the water around it to absorb that heat. And then once that is done, the water refreezes a little bit over the string, which is why you can pull the string out with the ice attached to it. Great. Someone said because the ice freezes over. That is correct. All right. So I have some questions for you all. Who remembers what is the freezing point of water? "32, that's awesome. And that is in Fahrenheit. And then 0 degrees in Celsius. All right, perfect. Someone asked, can you use the same string again? And the answer is yes. You do, however, if the string comes off, you have to redo the experiment, meaning sprinkle the salt over the string that's on the ice again. So it can go through the same process as it did the first time. All right. Another question I have for all of you is, what are some examples of where we can use the sticky ice in our real lives? All right, awesome. Someone said roads. That is correct. In states or places where they have a lot of cold weather, they sprinkle salt on the roads, so the roads become less dangerous because it keeps the ice melted and stick to the ground. Yeah, exactly, like New York. All right, another question is, can you create sticky ice without the water? Or do you need the water in order for the experiment to work? What do you all think? All right, a lot of people are saying that you need water, and that is correct. As mentioned in the experiment, you need the water to absorb the heat in order to melt the ice. All right, another question coming in is, does this type of string matter? The answer is no. You can use any type of string. All right, a question is, can you use rope? The answer is yes. As long as you have enough salt to cover all of like the surface area on the rope, then it should work. All right, there are a lot of questions of what materials you can use. And I would say that's the fun part of the experiment. If you want to try using a fork, will it work? In order to create the sticky ice effect. All right, we have a question. How do you use to stick the ice to the string? So to recap, first, you'll have 3 cups, one of salt, one of ice, and one of water. You're gonna pour the ice into the water cup and then lay the string on the ice. Then you're gonna use the salt and pour it over the string. That salt will lower the freezing point and then absorb the heat from the water. And then after 30 seconds, waiting a bit, it will freeze over the string. And then you can pull the string out with the ice attached.
Anika, if you'd like, I can replay the video for those that joined us later. It's only about 2 minutes, so I don't think people would mind seeing again if you want me to do that.
Yeah, that would be perfect.
Okay, let me go back to sharing my screen.
Hello, today we're going to be doing the sticky ice science experiment. The challenge is to lift an ice cube using only a string and salt. With a serious wow factor, this science experiment is a fun, simple way to learn about salt effects on the freezing point of water. So the materials you're going to need are 3 small bowls, one with ice, one with salt, and one with water, and a piece of string. First, we're going to place a few ice cubes in the water. Just like that. And then you're going to try to use the string to try to lift the ice out of the water. So here we go. As you can see, just like that. And then you're going to sprinkle some salt on top of it. And then we're going to wait 60 seconds and then lift the string. So what is the science behind the sticky ice? The salt sprinkled on the ice causes it to start to melt, just as salt added to icy roads does in the winter. The water freezes at 32 degrees Fahrenheit, which is 0 degrees in Celsius. But when the salt touches the ice, it lowers the freezing point to much lower than that. In order for the ice to melt, however, it has to absorb heat. The heat that is absorbed comes from what's around it, the water near the ice cube. Some of this water becomes so cold it refreezes and the string becomes trapped. The string is now stuck and you can lift the ice cube out from the water. So here we go. And whoa, would you look at that? As you can see, and there you go. You've just created sticky ice.
Great. So there we go. We've seen the sticky ice experiment again. And so I have a question for you, Anika. A lot of times we see them when they're spraying the roads that they're using a liquid rather. And so can you explain what they're using?
Sorry, in the middle you cut out. Could you repeat the question?
I apologize. I seem to be having trouble with my Zoom these days, and my there we go. I think we're back now. Can you hear me now?
Yes.
Okay. So a lot of times they'll be can you hear me?
Yes, I can hear you now, but you might have cut out.
Again. All righty, I'm going to have to shut my system down and start over, but I'll ask. They spray liquid on the ground rather than solid salt. Can you explain why they do that?
Yeah, so it could be when with the salt in the water, it's easy to distribute as well.
So why don't you share a little bit about yourself with us, Anika? Tell us how you got into the, the field that you're in today.
Yeah, so actually in high school, each year I would volunteer at Connect2STEM, and I really loved all the simulations and experiments and being able to interact with pre-med students or medical students during the experiments. And so that started just my fascination with science and wanting to go down the pre-med route. And then I also had the opportunity to shadow my pediatrician my senior year of high school. And I really loved how she interacted with her patients and the family and created that connection with them despite the heavy load of paperwork that she had to do after and before each appointment. Yeah. There are a couple questions in the chat. Can you use ice that is crushed? And yes, you can use any form of ice. Yeah, are there any other questions on the experiment? Yes, another participant asked, does it need warm water or cold water? Any form of water you should try to try for the experiment. I use room temperature water and it worked out perfectly. Another participant asked, do you need a specific type of string? The answer is no, you can use any form of string. Another one asked, would a toothpick work? And I would say, go for it, try. I believe it would work.
Are you seeing all those questions in the chat there, Anika?
Yes.
Okay.
All right. Someone asked, can we do the experiment later today and write it down now? Yes, of course. The session is also being recorded, and so you can also rewatch the video later on and write down the materials needed.
And we will be sending all of this out with information, with the links to the videos and to all of the supplies needed. So everything will be available in the follow-up. I like that question, if you think Legos would work.
All right. Someone said Legos wouldn't work because they think it's too thick. All right.
Has anyone asked the question about sticking your tongue to a metal pipe and why that happens?
Someone asked if they could try using their hands, and I would say go for it. When you try putting your hands there, fresh ice feels sticky because when you touch it, the ice will immediately freeze the moisture on your skin. And that's why the ice may feel sticky to you when you touch it.
We have time for a couple more questions. Anika, if you want to see if there's anything in there that you haven't answered yet.
All right.
Oh, using salt water. Interesting.
All right, there are a couple questions of would any other liquid other than water work, like juice? So you could try using the same materials with salt and seeing if it works. Just like using different types of string, using different types of liquid as well would be awesome. Mm-hmm.
That was a good question about if it's harder for the ocean to freeze over because it's salt water as opposed to fresh water.
Yeah, that's a great question. Well, in the experiment, we saw how the salt lowers the freezing point of the ice. So that very well could be the case.
Oh, great. I think this was a wonderful session. We really appreciate your sharing your time and knowledge with us, Anika. And we look forward to having you share more information with us next time we do our STEM sessions. So thank you so much. We appreciate that.
Thank you for having me.
Great. I am going to attempt to share my screen again. We will see how this works. Let's see here. All righty, I think we're good. So I want to play a quick thank you from our folks at the Be Kind crew.
Wasn't that fun? You did great. Do me a favor. Before the end of the day today, tell a friend or grown-up something you learned today. Be sure to check back for more Connect2STEM TV. There's lots more cool videos to check out. You know what? I should invite my friends to join the next session so we can work together virtually. Don't forget you need to register here. Special thanks to our sponsors, Banner Health APS, for their great support. For more nerdy ideas, follow Connect2STEM on Facebook. And here are some important reminders. Be kind, wash your hands, and mask up.
Well, thanks, Sunny. We appreciate that. And we've got another great session coming up at 9:30. I do want to share with you that we're very excited. We have a session this afternoon from one of our newest sponsors, Basis Schools. And so we're excited to have them with us. Coming up next, we've got Lucas coming back from our Aztec Center, and he's going to be talking about technology and simulation. He's going to be talking about virtual reality, augmented reality. So get your robot nerdy stuff on, and we're going to be seeing from him in just a minute. To ask you a couple of questions about some other things that are happening within our community that happen with STEM. I think she's there. Maybe she's not. Well, we just wanted to share with you that we're really excited about hopefully next year coming back with our live STEM day up at the Phoenix Biomedical Campus. But in the meantime, between now and then, we are really hoping to have some other activities coming up. So we will make sure and keep you appraised of everything that's happening with the University of Arizona and all of our partners on different STEM activities that'll be happening throughout the year. We have some great partners within the community that have wonderful activities going on with STEM. But as always, anytime you're interested in anything that has to do with science, technology, engineering, and math, please reach out to us at the University of Arizona. We've got you come present at your classroom. We've got just wonderful experts in all of those fields. So please reach out to us. We will have our contact information in the follow-up emails. Students, teachers, parents, please reach out. That's what we're here for. And we really look forward to engaging with you and continuing this partnership. So we've got just a few more minutes and we will have Lucas coming up. So just hang tight, run and get a bio break if you need to, grab some water, and we'll be right back.